Greetings, welcome, hello. All right, you wonderful chemistry fans. Today we're going to take a look at some more stoichiometry problems and how we are going to approach those. So go ahead and get out your pencils, get out your notes. We're going to go through some of these notes today. I'm going to make this probably just one long video, but I will let you know at which points you need to stop so that you can work on your homework assignment. You're going to have 3 homework assignments that you'll need to complete for me for this unit, and I will expect you to probably be pretty good with these types of conversions when I return on Monday. So, in the meantime, let's take a look at this. We talked briefly about this, but I want to go through it with you again one more time. Keep in mind, the whole purpose of stoichiometry is taking our reactants, figuring out how much we have of that, and then converting that to product. It's really great for industrial chemists, pharmaceutical chemists. It's an essential process to all chemistry. So when we look at this question, how many grams of chlorine are required to react completely with 5 moles of sodium to produce sodium chloride? Let's take a look and see what we can do to approach this problem. Much like with anything else, the first thing you need to do is to write a balanced chemical equation. So we look at the problem here. It's asking for chlorine, and we are reacting chlorine, which is again Cl2, with sodium. And it's telling us that we are producing sodium oxide. I'm sorry, sodium chloride. Always remember to look at your charges so that you write the product correctly. And now go back and balance your equation. 2 chlorines on the left, 1 on the right. 2 goes in front of NaCl. And then as a result, 2 is going to go in front of Na. Now, we need to be able to set up this problem properly. So, we need to look at the question here and figure out what do I know and what do I not know. How many grams of chlorine are required to react completely with 5 moles of sodium? Well, I am given 5 moles of sodium, and the question is asking for grams of chlorine. So now I need to set up my stoichiometry problem, again starting with what you know. Start with 5 moles of sodium. Moles of sodium is on top of the first step. It goes on the bottom of the next step. Now, I can do a couple things here. I could convert to grams of sodium, but that's not going to get me any closer to the answer. If I have moles of sodium, if you remember, we talked about the mole ratio. It is the only way you can convert between different chemicals in a stoichiometry problem. So we have to go from moles of sodium to moles of chlorine because we're going to eventually want to get to grams. You can see how this is going to be another step. Remember that the numbers that go here come from the coefficients of the balanced chemical equation. So I'm going to put a 2 here and a 1 here. I need to go one more step. And again, make sure you remember your rules. Moles of Cl2 here. Lastly, I can convert to grams. Remember, anytime gram to mole conversion, mole is always 1. Where do we find this information? Periodic table. 2 chlorines, it's going to be 70.9. Plug into your calculator and solve. I'm going to do that right now, so you should be doing it as well. 5 times 70.9 divided by 2. 177.25 with significant figures. We need 3 sig figs in our answer. And that's it. Okay? So again, make sure you approach the problem correctly. Figure out what you know, look for what you don't know, and find a way to solve. Remember, when I'm going from one chemical to another, I have to use the mole ratio. That's really, really important. So keep that in mind as we continue on through this. Calculate the mass in grams of iodine required to react completely with 0.50 moles of aluminum. It's the same process, folks. We need to write a balanced chemical equation. Iodine is reacting with aluminum. So aluminum plus iodine. Remember Brinkelhoff, right? I2. Our product here, this is a synthesis reaction. Ali. Always remember your charges and cross them. We need to go back and balance. 2 i's to the left and 3 to the right means they need to be 6. So I'm going to place a 2 in front of Ali3 and a 3 in front of I2. 2 aluminums on the right, 1 on the left. 2's got to go in front of that bad boy. And now I have my balanced chemical equation. So let's read and see what we want. Calculate the mass in grams of iodine required to react completely with 0.50 moles of aluminum. 0.50 moles of aluminum is my given, and the question is asking for grams of iodine. We start with 0.50 moles of aluminum. Again, keeping in mind, whatever's on top of the first step has to go on bottom of the next step. Now, I need to get to grams of iodine. I have moles of aluminum. Remember the mole ratio. I can go from moles of aluminum to moles of iodine. Remember, those are the coefficients of the balanced chemical equation. And now I go one last step to get it to grams. Mole is always 1 when I go moles to grams. And now I need to find the molar mass of I2. Each I is 126.9. Multiply it by 2, we're going to get 253.8. And now we're going to just plug in and solve, right? We need 2 significant figures in our answer, so let's see what we get. 0.5 times 3 times 253.8. Divide that all by 2. I get 190.35. 2 significant figures means it's 190 grams of iodine. Okay? That's all there is to it, guys. You just have to take it one step at a time. Start with what you know, solve for what you don't know. This mass to mole, it's the same thing. We start with what we know, we solve for what we don't know. This one we're just starting with grams rather than starting with moles. The question's still asking for moles. So let's see how we go through and do this one. Calculate the number of moles of ethane needed to produce 10 grams of water. Well, starting with ethane, producing water, odds are this looks like this is probably going to be a combustion reaction. So let's go through. We got C2H6. With the combustion, we're always going to add oxygen. And our products, CO2 and H2O. Okay, go through and balance. This is going to be pretty nasty. As you can see here, you go through and balance it. I'm going to save you guys some time. You're going to need a 2 there. All right. You're going to need 4, 6, 8, 14. This is going to be a 7. That's exactly how you want to go through and balance that, okay? But again, I would expect you to already know how to do that, but I'm just trying to save you a little bit of time. So, let's look at the question. It's starting with 10 grams of water, and it's asking for moles of ethane. Let's start. Start with what we know. 10 grams of water. Grams of water on top, meaning that grams of water goes on the bottom of the next step. The only thing we can convert grams of water into is moles. It's the only thing we know how to do with it, right? Can't do much else. 1 mole, water, find the molar mass, 18.02. We got mole of H2O on the bottom of the next step. Let's see what else we got. It's asking for moles of ethane. We can do that for sure. You can go mole to mole, right? That's the mole ratio we've been talking about. Those are given by the coefficients of the balanced chemical equation. So we got 6 and 2. Plug in your calculator and solve. 10 times 2 divided by 18.02 times 6. I'm going to end up with, again, you need 3 significant figures because that's what's given to you in the problem here. So 0.185 moles of ethane. Okay? And that makes me a happy chemistry teacher. All right? Same process here. Take it one step at a time. All right? How many moles of oxygen are required to make 10 grams of aluminum oxide? Let's keep going here. How many moles of oxygen are required to make 10 grams of aluminum oxide? If we're making aluminum oxide, we need aluminum and oxygen. Again, predict your product. Don't forget about your charges. And again, make sure you go back and balance your equation. We've done this so many times, guys. I'm not going to waste a whole lot of time with this. There's your equation. I read the question. Given and unknown. And now I can go through and solve. Start with what you know. $10.0, weird looking 0, sorry. And you know what, I'm just going to erase it. Love technology. 0.0 grams of Al2O3. Again. Only thing I can convert grams into is moles. One mole goes here. Al2O3, do the molar mass, 16 times 3 plus 26.98 plus 26.98. 101.96 for those of you keeping track at home. And again, we go one more step. No, guys, this isn't as exciting as throwing baloney on the ceiling or throwing baloney in places, but you know what? It's part of chemistry. It's part of math. Part of life. What do I want? I want oxygen. Go moles of oxygen. Again, these numbers are given by the coefficients of the balanced chemical equation. Again, keep in mind where they come from. I mean, we're going to make sure, draw little arrows so that you know where we get them from. This comes from here, and this comes from there, right? Now that we've got this all taken care of, plug in your calculator and solve. 10 times 3 divided by 101.96 times 2. 3 significant figures, so 0.147 moles of oxygen. That's it, guys. Okay? I know it's not nearly as exciting as throwing baloney or being crazy or getting chalk all over my pants, but, you know, not here. Make the best of what we got, okay? And again, it's really important that you know how to do this. So, all right, that's it for the first section of video that I want you to watch. Now I would like you to open up your course packet, your course booklet, whatever you want to call it, your textbook, your little thingy that Mr. Lamb gave you earlier in the semester. And I want you to do the next homework assignment, grams to moles, moles to grams. That should be homework number 26. in your course packet. Go ahead and work on that and try to get that done. All right, guys? Go ahead. So you go ahead and pause it. And you know what? I'm just going to make them separate videos. There's the first video. Congratulations, you're done. We'll move on to gram conversions later on. See you later, guys.